going to see about network simulator, that is NS3. So this is basically an open source, extensible, core and discrete event simulator. So this is completely different than predecessor of NS2. Through porting NS2 modules written in C++ is possible. This particular repository is completely maintained at www.nsnam.org. So the highly modular and added features compared to NS2, such as direct code execution, that is code to be written in C++ as well as Python. So it is a open, as I said, it is an open discrete event network simulator targeted especially for research and educational use. So as I mentioned, we have a set of libraries written in both C++ as well as binding available for Python. We have around projects of 3 lakhs lines of code, mostly written in C++. NS3 code does not provide any integrated development, modeling, visualization or computational environment. It is mainly supported in Linux, no backward compatible with NS2. NS3 has more detailed models for upcoming networks like long-term evolution, 4G, 5G, IoT, Wi-Fi related applications. NS2 is basically written in OTCL, that is tool command language, object tool command language as a scripting environment, whereas NS3 uses C++ program or Python script to define simulations. Python is often a glue language in all parts of today's programming environment. It is a GNU GPL version 2 licensed project. NS3 is not backward compatible, as I have already informed. The set of features, packets can have virtual 0 bytes for dummy data application that don't care about memory. Certain things are given in optional features. We can configure as IPv4 stack or IPv6 stack. Mobility model is not needed. If you want, we can have our own specification for mobility models. It supports cross-layer environment, as well as it has an added feature of packet capturing as well as tracing features incorporated in this module. Real world integration. So we have a pcap files. We can able to analyze the pcap files with the help of Wireshark, or we have a command in NS3. Through that command in terminal, we can able to extract. It is a real-time scheduler. We have set of modules supported in this. We can do practices in antenna, medium access control, LTE, Wi-Fi, various topologies, WiMAX, UMTS, 6LoWPAN. So we have a set of modules as a built-in. It is available in NS3. So if you look at the software organization of NS3, we have a core that is going to be a backbone. This is going to have a set of callbacks and tracing features associated with the log variables. On top of that, we have a network stack where I have said we have a option for us to configure in terms of the MAC as well as net ID. We have IPv4 or IPv6. On top of that, we could able to port mobility in mobility different models. It may be a static or a random walk, or any user defined models can be imported, written and imported. On top of that, we can do a set of devices. We can configure and we can set the propagations, and this is how the entire schema of NS3 looks. So if you look at the setup classes, nodes, this is nothing but a set of computers, n nodes, host. We have something called application class, the user level software that make use of underlying networking. There is no concept of user level. It's a system level application. So channel, it can be a Wi-Fi channel or CSMA channel, point-to-point channel, multi-point channel. So these are the different link with capacity and data rates. For every links are configurable. We have another class called net device, network interface that allow a node to communicate through a channel. We have a container and a helper class. container wrap devices together into one object, help us provide easy object to implement simulation and startup technology. So if you could see the conceptual view between a general client server model, we could have application, protocol stack and device. This is how the packet flow happens. But if you look at with respect to the development of the stack, we have a net device, chosen device. On top of that, we have to write the network stack, and then we configure our application. This is what any host is concerned. So if you could see the packet flow traversal that begins from source node to the end destination node. So it origins from application, goes via protocol stack and reaches the application layer, that is net device. Then through channel it traverses and reaches the other end. In the processing could happen in the reverse direction. If you could see the real implementation, so this has been cornered, that is application. We have a socket implementation, IPv4 routing. We have a protocol to send the information, protocol to send receive the information. We have an interface, we have a net device. The same setup could be configured in the destination node as well. This is what we proclaim as node. So if you could see here the code snippet what is given, we have a set of includes must be included in NS3, that is core module, network module, internet module, point-to-point module, application module. These are all the minimum preliminary header files must be included. And then we have a namespace. I think this is very important feature in NS3 object. So we could able to create multiple projects which works one another through the distinguished through namespace. We have a option to enable the log component. So that is the reason why we have here. So I think in this application is concerned, we just created simple client server model which works on a UDP echo. So that's the reason why we are capturing at both ends, that's UDP echo client as well as UDP echo server. So as I mentioned, we have two nodes. So how do you create node? We have a net node container class. We have created the object called nodes. Nodes.create of 2. This 2 indicates two number, one for echo client, another one for echo server. So here we could see, as I mentioned, we have a topology to configure, that's a point-to-point link exists between these two nodes. We have a data rate of 5 Mbps. We have a delay of that particular channel is 2 Mbps. This is how we configure the point-to-point channel. When it comes to net device, so we are just installing that net device into the point-to-point link. We have configured a protocol stack, that is stack.install. So we have installed that particular into the stack. We have a configuration in terms of the IP address, that is internet address here, and this is the base address. So we have assigned a port number for this application, that is server with the port number 9. Then here we have a echo server install at 1, that is it just starts at 1, ends at 10. This is how we will configure it. So when it comes to echo client, we will be setting the max packets interval packet size. So the same node client node we are installing it, but client runs at only between 2 and 10. So at the end we will be calling the run method to start the simulation. Once it completes it, we are calling the another method destroy to relinquish all the memories created for that particular application, and we will be closing that application, that is return 0. So how to run this particular any NS3 application? We have something called WAP. I think the detailed explanation was given in the document. We can go through that, how to install, how to configure all these setup. So for a simple case, I just wanted to show you an application between a client server. So we just created a simple with respect to just created something called my first.cc. So whatever the explanation I was given, so we just have that particular concept here. The setup header files have included. The log files, 2 nodes, and the path server with the port number 9, and the server runs at between 1 and 10 second, client runs at between 2 and 10. So this is a simple scenario what we have created for a so how to run this. So we have a command called /wap -run. This is actually located inside a NS all-in-one 3.20. Inside we have NS 3.20. Inside we have a scratch, but /wap is there only in NS 3.20. So scratch my first.cc. So this is how we have to execute that. So as I mentioned, at second client started the application, sending to the server, which is running at port number of 9 with the IP address of 10.1.1.2. So this is just echoing, this throws back. So this is what the scenario we call it as. So this is what the same output represented over there. When it comes to the modules, the clarity, this is what the setup module header files have included. This is for log component. This is how the main starts, capturing the 2 nodes have created, one for client, another for server, which indicated 10.1.1 is for a client, 10.1.1.2 is for a server. The point-to-point link, the data rate delay, how to install, how to create a internet stack, how to create an application for the client, UDP client and UDP server, how to run the simulation, when to start, when to stop. This is what through WAP, how do you build that application, how to run. So this what we have done was in terms of wired environment. Let's see now about sample scenario about wireless. So we will take n number of nodes, that is the scenario is something like this. We have a point-to-point node, that's N0 N1, and we have a LAN, that is LAN network is connected with the N1 endpoint of the point-to-point link. It consisting of 4 nodes in the it comprises of the LAN comprises of the 4 nodes that from N1 to N4, whereas Wi-Fi node that is from that is connected at N0, that is access point. So we set up nodes, that's Wi-Fi nodes N5, N6, N7. So with this scenario we will be creating a wireless environment. So as usual, we will be having a set of command line. The nodes container Wi-Fi station nodes. So Wi-Fi station nodes dot create, that is when n number of Wi-Fi nodes you're going to have. Then point-to-point link, setting the channel parameters, setting Wi-Fi L for node, station manager for Wi-Fi, MAC setting, service subscriber ID for the Wi-Fi MAC node, installing MAC node, setting configuration for the mobility of since it's a Wi-Fi mobility node, mobility model must be bundled. So installing CSMA nodes, Wi-Fi stations, setting IP address, configuring the IP for global routing, trace all, running the emulation. So if you could see in this application, we have dedicatedly written a code to generate PCAP files. How to extract the PCAP files, that is tcpdump -nn space -tt -r, any name whatever we are given in the file, that is that name.pcap. This is how it just extracts and shows the informations. We can even plot the GNU plot. So here this is how we have just plotted the GNU plot in terms of the congestion window parameters. So let's move on to a simple tutorial, creation of nodes and facilitating communication between them in point-to-point. So start with, as we have already come across, how to create a node, how to include, what is the flow, start with the main, creating LAN, point-to-point. A sample code so the same code we have executed and demonstrated. Thank you for your attention. When it comes to the practices, this source code file I have just shared with steps for the execution. What we have done, that is given in the experiment 1. Number 2, connecting two different types of network, that is point-to-point node and LAN. So scenario with the code is given, as well as execution steps are given, just follow that. Connecting nodes wirelessly, that is Wi-Fi node, execution steps. Ad hoc networks, that is MANET, mobile ad hoc networks, how to configure and execute. We have, based on this, we have just given some exercises. This is based on UDP client. A clear steps have been given, so for which how to develop. So similarly, another lab assignment, how to create a TCP node and how to configure. This is basically C++ code execution steps. Then we have some of the common practices, how to develop RTC, CTC based MAC, wave network, that is for vehicle ad hoc networks, WAN. So these three things I will be explaining to you in tomorrow's session, because this is going to have a important perspective in terms of MANET. Second one is in terms of WANET. Third also in terms of the WANET demo. We will see about some more applications, that is in terms of LTE as well as LTEA towards cellular setup applications, as well as we will see some of the 6LoWPAN application, which is very predominantly important in terms of the IoT context. So that is what the overall agenda of my talk in tomorrow's session. Thank you.